Now let us see what happens on intermediate machine, that is the machine B and machine C. We have studied the data encapsulation process happening on machine A, which is the sending machine, and we have studied the data decapsulation process happening on the receiving machine, that is the destination machine. But the TCP/IP stack of intermediate machine B and C also plays some role in forwarding the data. So let us see what happens in the TCP/IP stack with respect to machine B and machine C, which are neither sending machine nor receiving machine, but they are forwarding machines. So let us say that the machine B receives the data from the machine A. Again, the data link layer of the machine B picks up the data from the wire. It detaches the MAC header, and the data link layer hand over the rest of the packet to the layer running above it, that is the network layer. Now, as I said that machine B is a forwarding machine. It has to forward the data to the destination machine D. So network layer on the machine B will check that the destination machine that is specified in the network header is not equal to machine B. That is, machine B now knows that this packet is not for me. Therefore, machine B decides to forward the data to the next hop towards D. Now, which is the next hop machine which leads to machine D from machine B? Such a next hop is machine C. So network layer on machine B ships the data back to the data link layer. And now the data has to travel from machine B to machine C, that is between B and C. Therefore, a new MAC header is prepared by the data link layer and attached to the message. This new MAC header will contain the MAC address of the machine B and the MAC address of the machine C, that is hop by hop. That is hop by hop. And the data link layer eventually places the data on the physical wire or the link. So the point to note here is that on the intermediate machine, that is machine B and machine C, data encapsulation and data decapsulation happens between data link layer and network layer. The transport layer do not play any role on intermediate machines. The same thing, exactly same thing happens on intermediate machine C. So to summarize the entire process of data transmission from the machine A to the machine D, the diagram shows the journey of the packet through the TCP/IP stack of all the machines. So you can see that on intermediate machine B and machine C, the packet goes from physical layer up to the network layer in the TCP/IP stack, and then from network layer back to the physical layer. That is like this. Right? So that's all about data encapsulation and decapsulation. So note that data encapsulation and decapsulation partially happens on intermediate machines. Why I am saying partially? Because encapsulation happens from network layer till up to physical layer, and decapsulation happens from physical layer up to network layer. The transport layer do not play any role on intermediate machines. Another thing to note here is that whenever the machine decides to forward the data to the next hop, it updates the MAC header. So between machine B and machine C, the MAC header will be the MAC address of the machine B and MAC address of the machine C. And in between machine C and machine D, the MAC address would be the MAC address of the machine C and the MAC address of the machine D. So MAC address keeps on changing hop by hop. We will formally study all this process in detail when we will be learning L2 routing, L3 routing in the subsequent modules. So going forward, let us summarize the layer functions. That is the function of each layer in the TCP/IP stack. So as you know that the transport layer encodes only the application identities which are communicating with each other. Therefore, transport layer has the responsibility of process to process delivery. Transport layer knows about the receiving process as well as sending process, but transport layer do not know that application 2 is running on which machine in the network. You can see that in the transport header, we encode only the process information. We do not encode about the machine information. That is, we do not encode any identity of machine D or machine A. Similarly, the role of the network layer is to deliver the data packet from source machine to destination machine. Network layer knows nothing about app 2, but network layer knows that what is the destination machine and what is the next hop to reach D. So this information comes from the network layer, but network layer is not aware that on a destination machine D, which is the process to communicate, that is app 2. So you can see that in the network layer header, we encode only the source machine and destination machine identity. And next comes the data link layer, which is responsible for hop by hop traversal of a packet. The data link layer knows only the information about next hop. The data link layer do not know anything about the receiving process or sending process, that is app 2 or app 1, and the data link layer do not know that where the packet is eventually destined for. So you can see that each layer in the TCP/IP stack has its own share of interest, has its own share of information which is used in taking the packet, which is used in actually setting up the communication between application 1 and application 2. So all these layers combine their information, put together and use the information intelligently to make the communication possible between the processes running on different machines in the network. So going forward, let us summarize the data encapsulation and decapsulation concepts. So each layer has its own well-defined functions to perform. All layers of the TCP/IP stack work closely to make the packet journey happen from application 1 to application 2. Responsibilities of each layer is well defined and isolated from each other. Each layer hides its own information which is abstracted away from the layer above and below it. For example, the network layer doesn't need to know anything about app 2. All network layer knows that which is the source machine and destination machine. It do not know that what application process are trying to communicate. And also the network layer do not know anything about the MAC layer info of next hop. To illustrate this, that is, the network layer knows that the next hop machine is B, but what is the MAC address of machine B? That information network layer do not know. The network layer relies on data link layer to know the MAC address of the machine B. Now when you will be learning L3 routing and L2 routing combined together, you will know that why would you need the MAC layer information of the next hop machine. So let us discuss some terminologies here. When the application generates a data, that piece of data is actually called data. When that data is passed to the transport layer, we call that piece of data as segment. When segment is passed to the network layer, we called that chunk of data as packet. And when the packet is handed over to the data link layer, then we call that chunk of data as frame. So you can see that these are the different terminologies that is used at different layers of the TCP/IP stack. If somebody tells you a frame, it means that he is talking about the data link layer. If somebody is talking you about the segment, it means that he is talking about the segment. He is talking about the transport layer. And eventually, when the data is placed on the wire, we just refer to that data as bits. Right? So I hope the terminology is very much clear.